Welcome back. This is a Aleks homework video on identifying the parts of an atom. I think this is very easy. I think you may get this with no trouble. You may not even watch this video. You might not need it. It's going to ask you a lot of questions. There's a lot of places you can make a mistake and have to do this over. So being very careful would probably benefit you greatly. If you remember, there are three subatomic particles. There is a proton, and it is a positive particle located in the nucleus of the atom. That's A here on this schematic. You have a neutron. A neutron is neutral. Okay, we're going to say it's neither positive nor negative. It's also in the nucleus. So the protons and neutrons, both of them are called nucleons, they're equal, almost equal. They're pretty close to the same weight in terms of a particle. So massively, they're just about the same. In fact, when we call an AMU is an atomic mass unit. This is the number you see that's written in red on the periodic table that gives you the masses. So the masses that you see on the periodic table are simply the masses of protons and neutrons divided together. So they're so close that they just took a proton and a neutron and divided by 2. And so that's an atomic mass unit. So we could just say that they're equal to each other. A proton is going to have 1 AMU. A neutron also is going to be given 1 AMU. They're equal in mass. An electron is negative in charge, and it has almost no mass. It's teeny tiny compared. So if you were to take the mass of a proton or the mass of a neutron, whatever that mass is, an electron is 1,800 times less. All right, so 1,800 times would be like 1/1800th. And if you took 1 and divided by 1,800, you're going to get this as a decimal. Okay, so it is 5/10,000ths of an AMU. So it's negligible in mass, but it's equal in strength of charge to the proton. These are opposite of each other. The electron is in the shells around the nucleus, so it would be at B here. So you're going to do symbols. Okay, the other one would be symbols. You're just going to see a symbol would be a P with a superscript positive. That's P positive, or proton. A neutron is going to be an N with a 0 as a superscript, and the electron is going to be an E with a negative superscript. Okay, so if you're careful, this is not a big problem. This is not hard. There's just lots of questions here. You could get them wrong if you're not careful. Also, it's possible that as you have these problems, they're just random. So you might have 3 neutrons, or a proton and 2 neutrons, or 3 electrons. I don't know what you're going to have. You don't know what you're going to have. They're randomized on the computer. So in this case, it looks to me like I've got 2 negatives, or 2 electrons, because here's my charge, okay, in multiples of the electron energy. This is a -1. Well, that's an electron. An electron is negative. Proton would be +1. Neutral would be 0, would have a 0 charge. So a neutron would have a 0 charge. I'd put a 0 in there. An electron is a -1. That means that these are the same. That means that this is also an electron. Well, what's the symbol for a neutron? Well, it's an N with a superscript O. Okay, 0. An electron is an E with a superscript negative, and there's 2 of those. I'll put those. And then when you have the drop-down menu, it's going to give you the choices. So it'll say 1 AMU or 0.0005 AMUs. Those are really your only 2 that you need to worry about, because 0.0005 is 1/1800th of a proton or a neutron. 1 atomic mass units, which is the average between the 2. So if you were going to pull this one down, you would pick the same as here, 0.0005 AMUs. But a neutron, when you pull it down, is just going to give you one AMU, 1.0 AMU. And then where it's located on the diagram, the neutrons and protons are all found at A. Okay, so this would be at the location A. Electron here is found at B, and this is also an electron, so it's found at B. So I don't think you'll have any problem with it as long as you can keep your just calm down and just take it one step at a time. I think you'll be fine.